Good morning, dear students. So, we have come across what is a matrix, what are the properties of matrices, that is regarding the operation of matrices, multiplication, addition, subtraction, etc. and so on. Now, today we will discuss about a new topic that is called the transpose of the matrix. It is called the transpose of the matrix. Transpose of a matrix. Now, what do you mean by transpose of a matrix? Suppose you have a matrix A. Matrix A is equal to Aij of order m by n. Now, from A matrix, we are finding out a new matrix by interchanging the rows and columns. Let us take one example. A is equal to 2, 3, 1 by 2, 0, minus 1, 3 by 4. It is of order 2 by 3. Okay. Now, transpose of a matrix is obtained by interchanging rows and columns. Interchanging rows and columns. What do you mean by interchanging? That is, the rows of a matrix will become the columns of the transpose. Again, the second row will become the second column of the transpose. So, we can write in short form A transpose. A transpose is written as A dash or A raised to T. A dash or A raised to T. It is equal to interchange. That is, the first row becomes the first column. 2, 3, 1 by 2. Second row becomes the second column. 0, minus 1, 3 by 2. So, what happens to the order of the matrix? The order of the matrix becomes 3 by 2. A simple topic, transpose. So, transpose means it is a matrix obtained by interchanging rows and columns. Now, let us come to the definition. Let A be a matrix. Now, is it a square matrix or a rectangular matrix? Yes, it is a rectangular matrix because M and N are different. M is the number of rows, N is the number of columns. Now, how can you get A transpose from this? A transpose is equal to, how can you write the general form? Here I is the row, J is the column. So, when you find the transpose, it becomes J row, I column, and the order becomes N by M. N by M. This is called as the transpose of the matrix. Now, not only for rectangular matrix, this is applicable for square matrices also. Let us consider another example B. Another example B. B is equal to 4, 3, 2, 1. It is of order 2 or 2 by 2. What will be B transpose? B transpose is equal to, first row becomes the first column, 4, 3. Second row becomes the second column. But here still the order remains the same because it is a square matrix. I hope all of you understood transpose of a matrix. Again, repeat, what is transpose of a matrix? Yes, transpose of a matrix is obtained by interchanging rows and columns. Rows becomes the columns, columns becomes the rows. Now, transpose of a matrix has certain properties and most probably you will get questions from that section. What are the properties of transpose of the matrix. First property is properties. What is the first property? A transpose, the whole transpose is equal to A. That is, if you find or if you do the transpose twice, you get the same matrix. Let us take a simple example. A is equal to 2, 3, 4, 1, 2, 6 of order 2 rows, 3 columns. Here I am doing the examples. A transpose is equal to row becomes the columns 2, 3, 4, 1, 2, 6 of order 3 by 2. Okay. Now I am finding out its transpose. A transpose, the whole transpose is equal to the row becomes the column. So it will be 2, 1, 3, 2, 4, 6 and it is of order 2 by 3 and you can verify these two are equal. So we can say A transpose the whole transpose is equal to A. A transpose the whole transpose is equal to A. Second property is Ka the whole transpose is equal to K into A transpose, where K is any constant. K is any constant. Ka the whole transpose is equal to K into A transpose, where K is any constant. Let us consider the example. K. Let us consider a matrix A is equal to, I am taking a 2 by 2 matrix 4, 6, 3, 1. K is a constant. That means I am taking 3A. That is, how do you get 3A? Multiply every element by 3. 3 4s are 12, 3 6 are 18, 3 3s are 9, 3 1s are 3. Now, I will find out what I have to find out. Ka the whole transpose. 3A the whole transpose is equal to, a row becomes a column 12, 18, 9, 3. Okay. Now, next thing I have to find out K into A transpose. I will write this symbol in a uniform way. Okay. Now, 3A the whole transpose is equal to, now from here you can see that all the elements are having a common factor, isn't it? Uh, 3A the whole transpose. All the elements are having the common factor 12, 9, 18, 3. So I can write this as 3 is common. 3 into 3 4s are 12, 3 3s are 9, 3 6 are 18, 3 1s are 3. So what is this equal to? K into A transpose, or 3 into A transpose. So 3 into A the whole transpose is equal to 3 into A transpose, where here I have taken a constant K is equal to 3. This is the second property of transpose. Is it clear to you? Yes. Okay. Now the third property is, for any two matrices of the same order, for any two matrices of the same order, A plus B the whole transpose is equal to A transpose plus B transpose, and also A minus B the whole transpose is equal to A transpose minus B transpose. Now, you have to memorize these rules. At the same time, in the exam, they may give you two matrices A and B, and you may be asked to verify A plus B the whole transpose equal to A transpose plus B transpose, or they may ask you to verify A minus B the whole transpose is equal to A transpose minus B transpose. We will discuss through some examples. So, examples are done on the right hand side. Now, let us consider A matrix is equal to 2, 3, minus 1, 4, 6, 5 of order 2 by 3. So, A and B should be of the same order. B matrix is also of order 2 by 3. 3, minus 2, 0, 4, 2, 1. Now, what is a property? I have to verify A plus B the whole transpose is equal to A transpose plus B transpose. This is what I have to check. So, I'll start with LHS. What is a LHS? LHS is A plus B the whole transpose. So, first I will find out A plus B. All of you know how to add two matrices. It's quite easy. That is, what is A plus B? Orders are the same. So, add the corresponding elements. 2 plus 3, 5. 3 plus minus 2, 1. Minus 1 plus 0, minus 1. 4 plus 4, 8. 6 plus 2, 8. 5 plus 1, 6. And you get the same order 2 by 3. The LHS is A plus B the whole transpose is equal to, how do you get the transpose? One of you give me the answer. Yes, how do you get the transpose? Interchanging rows and columns. So, row become the column. 5, 1, minus 1, 8, 8 and 6. And what will be the order? It is of order 3 by 2. So, this is your LHS. Now, coming to the RHS. RHS is A transpose. A is a 2 by 3 matrix. So, A transpose will be, first row becomes a first column. 2, 3, minus 1, 4, 6, 5. And it is of order 3 by 2. And what is B transpose is equal to? B transpose is equal to, again, row becomes a column. 3, minus 2, 0, 4, 2, 1. It is of also order 3 by 2. Now, we have to find out A transpose plus B transpose is equal to, what should you do? Add the corresponding elements. 2 plus 3, 5. 4 plus 6, 4 plus 4, 8. 3 plus minus 2, 1. 6 plus 2, 8. Minus 1 plus 0, minus 1. 5 plus 1, 6. And it's of order 3 by 2. Now, let us see. This is your RHS. What about the LHS? 5, 8, 1, 8, minus 1, 6. So, what is the final result you are getting? LHS is equal to RHS, or it shows that A plus B the whole transpose is equal to A transpose plus B transpose. This is the third property. For any two matrices A and B of the same order, A plus B the whole transpose is equal to A transpose plus B transpose. Similarly, we can show that A minus B the whole transpose is equal to A transpose minus B transpose. This one I am giving you an assignment. Okay, so now we have discussed three main important properties of transpose of a matrix. And the last property, very important property for any two matrices, A and B, AB the whole transpose is equal to B transpose into A transpose. AB the whole transpose is equal to B transpose into A transpose. That is AB. It means multiplication. A into B is equal to A into B. First you find out A into B. Its transpose is equal to revertible order. B transpose comes first. B transpose into A transpose. This is also a frequently asked question. Now for the same question, excuse me, for the same question we will find out what is the solution. Now here I said we will discuss about the same question. What do you say? Can you find out A and A into B? Yes, very good. You cannot find A into B because number of columns of the second matrix should be equal to number of rows of the second matrix. So here what is not possible? AB is not possible. AB is not possible. What is the condition to find AB? Number of columns of the first matrix should be equal to number of rows of the second matrix. So, number of columns of the first matrix equal to number of rows of the second matrix. So, what will be the order of AB? AB will be of order 2 by 2. Okay, we'll take the example A. A is of order 2 by 1. What is the meaning of 2 by 1? It has 2 rows and 1 column. 2 rows and 1 column. 2 by 1. What is the meaning of 1 by 2? 1 row and 2 columns. 1 row and 2 columns. Okay. Now it is conformable for multiplication. Now let us find out AB. AB. So beginning itself you know the answer is a 2 by 2 matrix. How do you find? First row into the first column. 4 into 5, 20. Plus first row into the second column. Minus 8. Then first row into the first column. 4 into 5, 20. First row into the second column. First row into the first column. First row into the second column. Done. Second row into the first column. Second row into the second column. Minus 2. Now, what is AB the whole transpose is equal to? Equal to interchanging rows and columns. 20 minus 8, 5 minus 2. 2 by 2. Now, let us consider B transpose. What is B? 1 by 2. So, it will be 2 by 1. 5 minus 2. 2 by 1. And A transpose. A transpose is equal to 2 by 1. So it will be 1 row and 2 columns. 1 row and 2 columns. Now it is conformable for multiplication. Columns is equal to rows. So B transpose into A transpose. Answer will be 2 by 2. 5 into 4, 20. 5 into 1, 5. Minus 2 into 4, minus 8. Minus 2 into 1, minus 2. So we can say from this example, therefore AB the whole transpose is equal to B transpose into A transpose. So these are the 4 properties related to transpose of a matrix. So let us recollect once again. It's a simple topic, and based on transpose of a matrix you have some other topics also. So understand what is transpose of a matrix. Transpose of a matrix means it is a new matrix obtained by interchanging rows and columns. That is, rows becomes the columns and columns becomes the rows. Now what are the properties of the transpose? There are 4 important properties. A transpose the whole transpose is equal to A. Ka the whole transpose is equal to K into A transpose, where K is any constant. Now third one, if A and B are of the same order, because we are considering addition and subtraction, A plus B the whole transpose is equal to A transpose plus B transpose. We have done. A minus B the whole transpose is equal to A transpose minus B transpose. This one I have given you as an assignment question. And the last and the very important property is AB the whole transpose is equal to B transpose into A transpose. I have given you some examples also. I hope everyone understood the concept. Now we will do some questions related to transpose of the matrix. I hope everyone has completed the right hand side also. Okay. Take down the question, find the transpose. The question is find the transpose. Set matrix 5, 1 by 2, minus 1. One of you should give me the answer. A. My question is, what is A transpose? First of all, what type of matrix is this? We are just reviewing also. What type of matrix is this? It is a column matrix. So when you find the transpose, yes, it becomes a row matrix. What is the order? 3 rows and 1 column. What is the transpose? 5, 1 by 2, minus 1. That means it will have 1 row and 3 columns. That is the transpose of the matrix. I hope all of you have done along with me. Okay. One more. 1, minus 1, 2, 3. B. Another one, give me the answer. The peculiarity is it is a square matrix of order 2. So what is the transpose is equal to? Transpose is equal to 1 minus 1. Row becomes a column 2, 3. And also it is of order 2 by 2. Okay. It's clear when you consider rectangular matrix as well as when you consider a square matrix. Now, the third question is, verify A minus B the whole transpose is equal to A transpose minus B transpose, where A is equal to minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. B is equal to minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. Now, this one property I have given you as an assignment, but now you are going to discuss it as a problem. You start from the LHS. What is the LHS? Okay, this is confirmable for subtraction because both the matrices are square matrices of order 3 by 3. What have you to first find out? You have to find out A minus B. That is, subtract the corresponding elements. Minus 1 minus minus 4. It is equal to 3. All I have to do along with me. This is it's nothing new. It is what you have studied already. 2 minus 1. 1. 3 minus minus 5. 8. 5 minus 1. 4. 7 minus 2. 5. 9 minus 0. 9. Minus 2 minus 1. Minus 3. 1 minus 3. Minus 2. 1 minus 1. 0. This is of order 3 by 3. Okay. What about the LHS? It is A transpose minus B transpose. So, you have to find out what is A transpose. Since you have done along with me, even if I stand here, I think there is no problem. One more thing we forgot. Sorry. What is it? LHS. What is the LHS? A minus B the whole transpose. Yes, you are correct. A minus B the whole transpose is equal to, rows becomes the columns. 3, 1, 8, 4, 5, 9, minus 3, minus 2, 0 of order 3 by 3. Okay, very good. You are attending the class. Now, next one, we have to find out A transpose. Quickly find out A transpose. A transpose is equal to minus 1, 2, 3, 5, 7, 9, minus 2, 1, 1. And order 3 by 3. And also find out B transpose. Minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. 3 by 3. What is your question? Your question was find A transpose minus B transpose. Minus 1 minus minus 4. It is equal to 3. 5 minus 1. 4. Minus 2 minus 1. Minus 3. 2 minus 1. 1. 7 minus 2. 5. 1 minus 3. Minus 2. 3 minus minus 5. 8. 9 minus 0. 9. 1 minus 1. 0. 3 by 3. Now, check A minus B the whole transpose and A transpose minus B transpose. 3, 4, minus 3, 1, 5, minus 2, 8, 9, 0. Clear? So, we have found out A minus B the whole transpose is equal to A transpose minus B transpose. So, the property is very well clear to you. You will take another example and then do it. Okay, now, next one. What is the question? You are given A transpose is given to you. What is A transpose? -2, 3, 1, 2. B matrix is given to you. -1, 0, 1, 2. The question is, find A plus 2B the whole transpose. Okay, see the question. You are given A transpose and B. Question is A plus 2B, that is scalar multiplication. Add, then find the transpose. But first thing, you have to get A. What is A? Or how do you get A? You know the property A transpose the whole transpose is equal to A. This is a property you are going to apply over here. So A transpose is given. So A transpose the transpose equal to -2, 3, -1, 2. Its transpose is equal to -2, 1, 3, 2. And this is your A. A is equal to -2, 1, 3, 2. Next you have to find 2B. How do you get 2B? Yes, multiply every element of B with the scalar 2. -2, 0, 2, 4. What is the next step? A plus 2B equal to -2, 1, 3, 2 plus -2, 0, 2, 4 equal to -4, 1, 5, 6. And your question is A plus 2B the whole transpose is equal to -4, 5, 1, 6. It's also an important question, frequently asked question. I hope it is clear to you. Now these questions are from exercise 3.3 in your textbook. So when you go home, open your textbook. Some questions are not done in the class, but similar questions you can do it at home as an assignment. Now, two matrices are given, A and B. A is equal to column matrix 1, -4, 3. B matrix, it's a row matrix, -1, 2, 1. The question is, verify AB the whole transpose is equal to B transpose into A transpose. Okay. So first of all, let us see whether they are conformable for multiplication. How many rows are there? 3 rows and 1 column. Here it is 1 column and 1 row and 3 columns. It's conformable? Yes. So what will be the order of AB? AB will be of order 3 by 3. So it should come to your mind that 3 by 3, that will have 3 rows. It's a big matrix, 3 rows and 3 columns. Okay. First row into the first column, 1 into -1, -1. First row into the second column, 2, 1 into 1, 1. Minus 4 into minus 1, 4. Next one is minus 8. Next one is minus 4. 3 into minus 1, minus 3, 6 and 3. AB the whole transpose. This is your LHS. Transpose, interchanging rows and columns. Minus 1, 2, 1, 4, minus 8, minus 4, minus 3, 6, 3. Now, on the RHS, you have to find B transpose first. B transpose is equal to row matrix becomes a column matrix. Minus 1, 2, 1. 3 rows and 1 column. A transpose. Column matrix becomes a row matrix. 1, minus 4, 3. 3 rows and 1 row and 3 columns. So, B transpose into A transpose will be of order 3 by 3. B transpose into A transpose is equal to first row into the first column, minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. And it is of order 3 by 3. Let us compare. AB the whole transpose and this is your RHS. Minus 1, 4, minus 3, 2, minus 8, 6, 1, minus 4, 3. So we can conclude AB the whole transpose is equal to B transpose into A transpose. Now in exercise 3.3, do the remaining questions, and next class we will continue with some properties of transpose of a matrix. I hope everyone has understood the topic and do the assignment. Thank you all of you.